Because why not? Because I hate talking in front of people, so instead I'll talk in front of the entire internet. Because why not? All right, so we're now sharing my entire screen. Kevin, I sent you the URL if you want to tweet it or something.
Yeah.
So for the people that couldn't be here, they can watch this tonight. Also, if I speak too fast or there was something that you thought was super cool and you want to go back and watch it again, that'll be available to you. Yeah. And I'm going to start a timer. I am going to keep myself to 40 minutes. I have way more than 40 minutes worth of content. So if I'm going too fast, it's your job to tell me that. Because if you're not following, that's my fault, not your fault. Okay? So I'm going to talk about this thing called Test Kitchen. How many of you have heard of Test Kitchen? Used it? All right. We got a couple of people that have used it before. Hopefully they'll stay really quiet because, as I mentioned, sometimes I lie. But everything is going to be just great tonight, I'm sure. So just a little bit about me. I like to put pictures of myself on slides. So if you get tired of looking at me, you can look at my picture. As Kevin mentioned, I do work at this company called Chef. And I run a podcast called The Food Fight Show. Let's see, what else can I tell you about me? Oh, my father misspelled my name because the rule in my house was mom picks the names and dad misspells them. So when we're done, if you want me to tell you how all of my siblings' names are misspelled, I will do that. But a little bit more about me, like I'm a sysadmin. I haven't always been a sysadmin, but there was a time in my life where I became a sysadmin, and it was awesome. And one of the things that I learned from developers was that they test all of their code. How many of you write unit tests for your code? And like integration tests and what have you, right? So there's all these different testing frameworks. But as part of my journey as a sysadmin towards this thing called DevOps, right? One of the things that I did early on in my career was I started going to lunch with the developers. And you know what I learned? These developers, well, I don't know what your prejudices are, but I will tell you that these were primarily Rails developers. So either that means nothing to you or it means something very specific to you. I don't know. But what I will tell you that I learned at lunch from these developers is that you can spend weeks and weeks at lunch arguing about what makes a good unit test and what makes a bad unit test. And you can spend those same weeks arguing about, is this an integration test or a functional test? And so I've learned these lessons deeply. They're deeply rooted within my psyche. And I was automating all of my infrastructure with this tool called Chef. And at the time, there was no testing in Chef. And then all of these test frameworks started coming out. And people got really excited about them. We started writing tests. I was told, as a member of the community, hey, you should test that Chef code. You should test it more often. And my immediate response, and by immediate, I mean I held on to this response for a good solid year, was look, the only thing I know about testing is I'm going to do it wrong. I'm going to write a bad test. I'm going to mislabel a test. I'm going to call it a unit test when it's actually an integration test. And I'm going to be really stupid when I do that. But there is a thing that I am well accustomed to because I'm a solid sysadmin. You know what I know how to do? I know how to write a Nagios alert. And so if I have an hour to spare in my day, I have a choice. I could write a shitty test, or I could write a really good Nagios alert that I could then dutifully ignore when it pages me at 3 a.m. in the morning. So which do you think I chose? I chose the Nagios alert every single time because I don't care about testing. All I know is I'm going to do it wrong. And frankly, there was this other thing that happens that I see all the time when I go out and I work with customers and they're getting started with Chef, and I have this exact same experience. One of the best things about Chef, or frankly, any of these automation tools that we use, whether it's Terraform or Salt or Ansible or Puppet or whatever you're using, one of the best things about them is you can write a line of code, put that code in production, and the entire production environment changes. And one of the worst things about them is you can write a line of code, put it into production, and the entire production environment changes because of that line of code. And so the result of this is I'm afraid of the system. I'm afraid of this new power that I have to just impact production. And so how do I respond to that? First, I write better Nagios alerts so I know when things are broken. But second, I slow down my activity toward getting to fully automate it because I'm afraid of the system. And what I learned over time is that testing can really help with that. Now, I put up a bunch of reasons why you might test. But for me, the fundamental reason that we test is so that I can build faith and confidence in the system, in the change that I wrote here on my laptop. As it moves through the pipeline and gets to production, it's going to do what I expect it to do. Now, another thing that I always was envious of developers. Look, I was working with Ruby developers. Before that, I was working with Java developers. I worked with Go developers. You know what those developers can do? You can write a Ruby program or a Java program right here on your laptop. And you can take that artifact, whether it's a jar file or well, if it's Ruby, there's no artifact. Maybe it's a gem. Maybe it's just a pile of code. You can take a Go binary and you can just put it on another system and it just works because you've tested it locally, and that's cool. The problem with being a system administrator is I'm working on a Mac. I don't have any Macs running in my data center. I don't have any Mac operating systems in my cloud. So how do I test the changes that I want to create? That was always a thing I was jealous of. You could test locally and have confidence that you could submit it into the pipeline. If it passed all the tests in the pipeline, it's good to go for production. That's not how it works for sysadmins. That's not how it works for us that are automating systems. So when it comes time to testing out your infrastructure automation, what do you have to do? First, you write the automation. You might do some static analysis on that automation. You might even do some unit testing, eventually some integration testing. You commit it to version control because you have to put your code in version control. What version control systems are you using? Git. Anyone? GitLab. GitLab is Git. It's the version control system that is there, foundational, right? What other version control systems do you use? Subversion, okay. As long as you're using the Git SVN plugin, that's cool. Look, you have to use a proper version control system. My criterion starts with GIT. How many of you use the BAK version control system? Yeah, you're laughing because you use it, right? It's not a thing to laugh about or be proud about. How many of you don't know the BAK version control system? It's when you take a file and you copy it to filename.bak, and then you modify the file, and that way you have a backup of that file. And frankly, those of you that said you aren't using it, I think you all lied. This network is open. I checked all of your inboxes. Everyone has a fucking attachment that says blah, 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 underscore final, underscore final NH, underscore final NH, underscore August 2018. We are using version control systems everywhere, and we need to fix that. That would be better. All right, I'm off of my version control system soapbox for a minute at least. All right, but this is how we test infrastructure, and it sucks because first, back in those early days when I was writing really bad tests, I was actually at a meetup and I was talking about some of the new unit test frameworks that we were doing, and there was a developer in the room who recognized that I was writing really bad unit tests. And he said, over that chef community, there's a whole lot of testurbation that's happening. And yeah, that was, and I realized at that moment he was right. We were writing bad unit tests that they felt really good. All of our tests were green, but it wasn't actually being productive at all. So what I really like to focus on now is integration testing. So I want to zoom in on that. So how do we actually integration test our automation that we want to do for our infrastructure? First things first, we have to create infrastructure that matches our production environment. And so how many of you in this room does it take 2 weeks or more to get yourself a virtual machine where you work? Yeah. How many of you have worked in a place where it took 2 weeks or longer to get a virtual machine where it works? When I, before I became like a professional sysadmin, I was working at a big software company before I was running systems. I didn't call myself a professional sysadmin then, but I kind of was running applications. And there was a time where I recognized that we needed more capacity. So I went to my boss and I said, boss, we need more capacity. The boss said, cool, here's how you get it. You fill out this requisition form, then we'll procure a server, and then we'll put it in the data center, and then you'll have more capacity. I'm like, great, that sounds super easy. So I filled out the form, he approved it, it went off into the black hole, and a mere 18 months later, I could log into that box in my data center. Capacity problem solved. There are many, many people in the world for which that is still the lived reality of the day-to-day work. So if you want to do integration testing, all you have to do every time you write a line of code, just wait 18 months for that VM to show up so you can test out that thing. That's a terrible way to go. But once you have that infrastructure, you then have to run the automation, verify that it worked, and deploy that infrastructure then. Or sorry, destroy that infrastructure. That's what Test Kitchen is all about. It is a test harness that allows you to do that testing on an individual node or an individual cookbook or an individual piece of automation. Now, some of the examples I'll use tonight are going to be very chef focused because that's the tool I know best. But I'm also going to show you some Ansible. I'll definitely show you, I mean, maybe show you some Terraform, and we'll talk about all of the different things. So, but given that I work for a company called Chef, and the name of this thing is Test Kitchen, I have to feel like this is a cooking show. So before we go any further, I'm just gonna take this awesome lasagna that I've already pre-made, it just hasn't been baked yet, and I'm gonna shove it in the oven. We're gonna come back to it later. So you'll just have to forgive me, because I'm also gonna do some live things for you. Well, for you, for me, I don't know who I'm doing them for. All right, I'm just gonna run this command over here. I'm not even gonna tell you what it does yet. You'll figure it out as we go through. All right, with that kicked off, imagine that as the lasagna or whatever it is that we just put in the oven. We're gonna come back to it at the end of the show. You're all gonna make these amazing faces about how good it tastes, because as we're watching on the video, we can't see how good we can only see how good it tastes. So, all right, so the first thing we need to do is get some infrastructure, right? So Test Kitchen is a tool that's gonna allow us to do that. It itself has a configuration file. Now, like all good configuration files of the modern era, it is a YAML-based configuration file, and it is called the kitchen YAML. And so what we're going to do, let's say in this example, that this particular piece of automation, we're going to test this automation on what is our eventual operating systems in production. And unlike you, our production environment uses multiple different operating systems. I know where you work, there's only one operating system in production, and it's the same version at the same patch level across every production system, right? Yeah, that's funny. Yeah, that's not really how it works. So this particular piece of automation, we're gonna target Ubuntu and CentOS for that. So what we do in our kitchen configuration file, the kitchen YAML, is we list them out here. So I want a platform named Ubuntu and one named CentOS. And then I'm going to create that infrastructure. So I'm going to create virtual machines or cloud instances or maybe containers for that. So I'm going to do that using a command called kitchen create. Pretty straightforward. Well, then you might have this question of where will it be created, right? So kitchen has a bunch of different options. For the first go through this, I'm going to use the Google Cloud, so GCE or Google Compute Environment. How many of you have used Google Cloud before? Okay, cool. What other clouds do you use? AWS, yeah, we could do it on AWS. But I also talked about the desire to do it locally. So we could just spin up a local virtual machine as well. But for the purposes of this first go round, we're just gonna create it on Google Cloud. So I'm gonna go over here and I'm just gonna run this command kitchen list. You'll see that I have two machines, Ubuntu and CentOS, that have not yet been created. So I run this command kitchen create -C2. Now the -C2 is completely optional, but what it means is do 2 concurrent threads of this. So this is going to reach out to Google's cloud platform. It's going to use their API and say, I would like 2 virtual machines, please. I want one to be Ubuntu 16, and I want one to be CentOS, did it say 7? Whatever my configuration says. And so it's gone out and it's created those 2 machines for me. And it did that in basically no time with no additional configuration. I just set that up. So that was super easy. I now have these instances that I can go and play around with. Now, even if I'm not doing any automation, that's a big help. I can just log in and start banging on those boxes, figure out what I want to do, maybe capture that in a wiki so that I can repeat it. Don't do automation like that. That's not automation. Don't put it in the wiki. It has to go in SharePoint, and then you know it's good automation. Okay, so next we're going to run SharePoint is great, I'm sure. So next we're going to run the automation. So how do we run the automation? Kitchen uses this verb called converge when we want to run the automation itself. So we're going to use Chef tonight as the thing, at least this time, to converge that environment. And what that really means, the verb or the word converge really means that when we execute that thing, we should get closer and closer to our desired state every time we run it. Hopefully we can get to our desired state the first time we run it. We shouldn't have to run it repeatedly, but who knows, maybe we will. So in the kitchen configuration file, there's a thing called a provisioner. And the provisioner is where you specify what are we going to use to provision that environment. Now, how many of you have written Chef before? All right, a couple of you. I'm going to show everyone else. I'm going to show all of us some Chef. Maybe someone who has never written Chef before. Could you tell me what this is going to do? Can you just guess? Make a wild ass guess what this is going to do. Oh, it's going to install Git. Look at that. See? Chef experts tonight. Also, that's Ruby. So now you can add 2 more things to your resume. You're a chef expert and you know Ruby. So that's cool. In plain English, what this says, you're right, it will install Git, but Chef is a little bit more nuanced than that. In fact, what Chef will do is it's going to say, if Git is not already installed, then install Git. But if it is already installed, it's going to do nothing, right? So I like to call this test and repair. It's going to test the system. Is it in this desired state that I want? If it is, leave it alone. If not, take an action. In this case, the action is to install that package. Now, if you've worked with Ubuntu and CentOS before, you know the command to actually install that thing is different on each one of those platforms. Chef provides this layer of abstraction above those commands so that we don't have to think about, do I do a yum install or is it an apt-get to install this thing? Which operating system am I on? It doesn't matter. Chef makes it easy. Okay, so I'm going to run the automation, and I do that using this command, kitchen converge. And so I'll run kitchen converge. I'll do it again in parallel. The nice thing about having that test infrastructure be off on a cloud is I'm utilizing those resources. The downside of using, say, virtual machines is Kitchen makes it very easy for you to spin up 24 virtual machines. Your laptop might not be very happy with you if you're trying to run 24 virtual machines and trying to automate all of those all at the same time. Although it's a good way to waste your entire day. Just tell your boss, converging. It's like compiling, if you will. Okay, so there we are. We ran the automation. That took 45 seconds, 46 seconds. It went in, made sure Git was installed. Now, that's not a whole lot of automation, but this talk isn't about how do you do Chef. It's about how do you test that automation. So the next thing I need to do is verify those results. And of course, I'm going to start with the lazy way. And we're going to find out that the lazy way is the wrong way, of course. But I can just log into those machines and check, is Git installed? And Kitchen, as I list them, I can see their names, default Ubuntu and default CentOS. Kitchen handles all of the underlying authentication infrastructure for me. So I can just run this, kitchen login Ubuntu, and it knows what IP address I'm going to. It knows which SSH key to use, which user to log in as. All of that is handled for me. So I can log in, I can test, is Git here? I can ask the system which Git, make sure that it's there. I can do the same thing on CentOS, make sure that that's there. And then we're good. We've automated this system. We've tested our automation. I have confidence in it. We can run it in production. The challenge, though, is that was one little package, right? And when we automate our systems, there's a lot more than one package that we have to install. We have to install a bunch of packages, configure them, maybe run a bunch of services. There's a ton of stuff that we have to do. So manually verifying that, terrible, sucks. How many people like manually verifying things? Yeah. None of you work in QA then, huh? Okay, good. Wow, sometimes I'm rude to people. That was rude. People in QA are awesome. They help us be safe. All right, so I want to introduce you to this awesome tool called InSpec. How many of you have seen or heard of InSpec before? All right, good. It's always good. See, this is really just a test of my coworkers. I'm gonna keep throwing out tools that we produce and make sure that they know them. Yeah, exactly. So what is InSpec? InSpec is a framework that allows you to validate or make assertions about the configuration of your infrastructure. So you can test to make sure that your infrastructure is set up the way that you like. Now, very few of you have seen InSpec before. Can someone tell me what the first stanza, so the first 3 lines of that code, is going to check for? Brian, why don't you tell me?
It's going to check that a service called Apache 2 is running.
Yeah, it's going to check that a service called Apache 2 is running. Does everyone kind of see that now? Now that he's described that or explained that to us, it's all very clear. Brian is really, really smart. So you should listen to what he says. He's probably right. So that's exactly what this is going to do. It's going to, in this case, this is just some sample InSpec code here. So Kitchen has another thing called a verifier and a phrase or a command that we can run called kitchen verify, and it will execute those tests for us. So we're going to use InSpec as our verifier. And this is the particular InSpec test that I'm going to run. Now, those of you that heard my story about I'm going to write bad unit tests or I'm going to write bad tests, this is proof positive that I'm going to write a bad test. It's a bad test because it's testing the same thing 3 different ways. I could probably do this with just one of these 3, but it's a presentation. It's not going to go into production. Also, it's test code. It shouldn't go into production. I just want to show some of the power of InSpec. So let's go ahead and verify our kitchen setup. We run kitchen verify, and sure enough, it's going to go out. It's going to poke both of those machines with this InSpec code. Now, as it's running, I'll tell you a little bit about InSpec. InSpec itself does not need to be installed on those remote machines that it's talking to. And in this case, it's just logging in over SSH to those machines, validating that they're configured the way that they want. There's nothing installed special for InSpec on those machines, and then coming back and reporting the results. So here we can see everything is good. So now I'm super happy. I can take this code and I can put it into my pipeline and get it into production. And I know that it's going to do what I expect in production. Or at least I hope so, right? My tests have seemed to validate that. But there's one thing I should do before I put them into my production system. And that is I should destroy these instances. I love Google, but I don't want to keep these instances running forever. Why pay for them? So Kitchen has another great command for us called kitchen destroy. And kitchen destroy will do exactly what you expect it to do. It's going to take those servers and it's going to blow them away. They're going to be gone. So here they go. And that brings us a full loop into our testing. So we figured out that we needed some new infrastructure. We created that infrastructure. We wrote some automation to run on that infrastructure. We watched it execute. We wrote some tests to validate it was what we expected. We ran that validation, and everything's good to go. Then we destroyed that infrastructure. So what questions can I answer for you so far about what you've seen? It seems super fucking complicated, right? I hope it doesn't. That was a joke. I hope it seems okay. I hope it's not too complicated. I don't know. Maybe it is super complicated. The best way to learn about it, though, is to do it. I want to introduce you to one final command after our destroy, though. And that's this command called kitchen test. The beauty of kitchen test is it's all of those things that we've just seen in one command. So kitchen test will first destroy any instances that are currently running, any kitchens that exist. We'll blow those away. Then it will create new instances for you. It will converge those instances, or it will run the automation for us. It will then run verify. And then if my verifications pass, it will then destroy those instances. Now think about this in terms of your pipeline. And I keep using that word pipeline. So pipeline is like I have code on my system, and I want to get that code into production. We put it into a pipeline that maybe will execute tests along the way. You might run some unit tests, some linting, what have you, to make sure that as it gets closer and closer to production, we know that it's going to do what we expect when it gets into production. So we could take this kitchen test command and we could bake it right into that pipeline. So every time we have an infrastructure automation code change, we send it through this pipeline and it runs kitchen test. So here I'm going to run kitchen test. It's going to create those. Well, first it will destroy any instances that exist. It will create our new instances. It will, in this case, install our provisioner. The provisioner in this case is Chef. So it's going to put the Chef client on there. Going to take our cookbook or our recipe and put that onto the system, execute the Chef client, which will install Git on those machines. Then it's going to run InSpec to validate that it's there. Once it sees that it's there, it's going to destroy those machines for us. And all of this is going to take, in sum total, with these two machines, about 3 minutes, which is faster than at least some people in this room can provision a VM back where you work. So think about the power of that. Now I have this easy way to build a lot of confidence in the systems that I'm building and the systems that I'm automating using this framework called Test Kitchen. So that took, what did it take? 3 minutes and 5 seconds. Pretty good, right? It's pretty cool. Let me share some additional Test Kitchen love with you before we move on to some other topics. So first, where do we create those instances? Tonight we used GCP, or we used the Google Cloud. Kitchen has drivers for just about anywhere you can think of that you might want to run infrastructure. So you can run infrastructure on AWS, you can run it on Azure. If you have an OpenStack cluster that you're running and managing internally, you can run it there. You can create Docker containers for this to spin up and test. You can run VMware instances, whatever you want. And if the way you run your infrastructure isn't on this list, there's probably a driver for it, so we can get you there. In fact, remember that thing we put in at the beginning of the episode, right? The thing we put into the kitchen at the beginning. Let's go back and check on that. It looks like it's completed. So I'm just going to run this command, kitchen list. except you can't see that, can you? Can you see that? Yeah. So I'm going to run kitchen list. And what we're going to see is while we were talking, and by we I mean the royal we, of course, while I was talking, what we did was we used this kitchen configuration to go off and spin up Ubuntu and CentOS instances on Google, on AWS, locally using Vagrant and VirtualBox, so those are just local VMs, and Docker containers. So I spun up 8 instances, ran that automation, and verified them, and now they're all good to go. I ran that with one command, kitchen verify -c2. So I did that concurrently with 2 threads. Yes, sir?
Can it handle different versions of Chef for the provisioner?
Yes, it can absolutely handle different versions of Chef for the provisioner. And one of the nice things about that is as Chef upgrades their versions, sometimes there are backwards compatibility issues with, say, your cookbooks. And so there's a flag that you can use in the kitchen configuration itself, in the kitchen YAML, called treat deprecations as failures. And so actually, as the Chef client runs, like the newer version of the Chef client runs across your older Chef cookbooks, if there are deprecations that the Chef, like deprecation warnings that the Chef client throws, the kitchen will fail and say this cookbook is no good. And so you can actually start upgrading your cookbooks so that you're prepared for the new version of the Chef client. Yeah. There's also another really great flag with a really terrible name. I don't know what the I don't know the exact name of it, but it has the word idempotent in it, which makes it terrible in my mind. But basically what it means is it will run the provisioner twice with the idea that the second time the provisioner runs, nothing should change. And so if something changes on that second run, it means that the first run wasn't enough to get you fully converged. And so we'll treat that as an error, which is also a really nice thing, because the beauty of Chef is like it's a wide open framework and you can do a lot of stuff with it. The downside of Chef is it's a wide open framework and you can do a lot of bad stuff with it if you so choose. I don't know, Brian, do you have any experience with that? Bad Chef code? Yeah. I thought you might.
Since you brought it up,
Yeah.
there was something really cool earlier that you showed, but you glossed over.
Oh.
If you go back to your InSpec slide.
Yeah.
Are you going to talk about this? You know what I'm going to say?
I don't know.
All right. So whenever he was testing for the presence of Git, notice that he just said is Git here.
Yeah.
And then notice that he was also using Ubuntu and CentOS, which use different package managers. There's an RPM.
Totally.
And
Yeah.
And then there's an after whatever,
Yep.
or depackage.
Yep.
So the cool thing is that not only was he able to test this on different machines, he doesn't have to worry about what command to run.
I don't even care what command. The same way I installed it, just said package git should be installed. On one machine, what Chef is going to run under the covers is yum install Chef, and on the other, it's going to run apt get install Chef, right? And then testing it, same thing. I don't care. InSpec provides that abstraction layer for me, which is super powerful.
Because you mentioned this, and I was in
Yeah.
a previous discussion
Yeah.
with you.
Yeah.
And you mentioned, first off, that this goes through and uses an SSH client.
Yes.
In a previous discussion, you actually
Yeah.
also said
Yeah.
it works on Microsoft.
Yeah, absolutely. So the way InSpec will work one of 4 ways. You can install InSpec, the library itself or the tool itself, and the tests that you want to run locally. So I can run InSpec locally on this machine. I can run InSpec across SSH. And so if I run it across SSH, all I need is an SSH connection to that remote machine. InSpec does not need to be installed there. In executing it, it's not going to install InSpec. It is literally just inspecting that machine. It's not changing the state of that machine or the configuration of that machine. In addition to SSH, you can use WinRM. So same rules apply. There's nothing installed on that Windows machine. It's just making a Windows remote management connection to those machines. And then the 4th way that you can run it is across the Docker API. So if you're running a bunch of Docker containers and you want to make sure that SSH isn't running inside of your Docker container, you could write an InSpec test that says there should be no SSH inside this container. Also, if you're running SSH inside your Docker containers, you should probably talk to someone at the end of this talk. Brian would be a good person to talk to for sure. Yeah. Not that Brian, this Brian. Talk to the right, well, you can talk to either Brian, it's cool.
To clarify, it wasn't me.
Yeah, you're right.
So with the abstraction that you showed,
Yes.
work equally on Windows as well.
Yeah, so it would, provided that Windows has a package. So the thing that was interesting there was that the name of the package happens to be the same. So that made it easy. So if Windows has a package named Git, whether it's a chocolatey package or what have you, it will check to make sure that that package is there for it. Yeah, exactly. And of course, that string GIT, that was the name of the package, that could be a variable in our code. So we could do some switching if we knew that we had to. Now, the other thing that's important about Test Kitchen, or that's cool about Test Kitchen, is the provisioner we used was Chef. And that's awesome. I work for Chef. I get paid by Chef. I think Chef is the bee's knees, but I don't care what provisioner you use. You can use any of these other tools as well. So you could use Ansible, SaltStack, Puppet. There's even a CF Engine provisioner for Test Kitchen if you're using CF Engine in your organization. And if you are, that's pretty awesome. You should keep doing that. So let's just look at an example of provisioning with Ansible. So here I'm just going to run a little kitchen verify. So this is no instance exists. It's going to, this is the nice thing about Test Kitchen also. If you skip ahead in that workflow, it recognizes that I didn't create the infrastructure or converge it. So here it's created it. Now it's applying an Ansible playbook to this particular virtual machine that I'm running. And then at the end, it's going to run the kitchen verify. I would like to hide that thing. This is why I'm not a dentist. Ooh. Well, that wasn't what I hoped would happen. All right, but you trust me. Oh no, it's still going. Good. You don't even have to trust me. There you go. So in 55 seconds, it did all of that stuff with Ansible as well. Now, the same is true about the verifiers. So you can use server spec as your verifier. You can use Pester as your verifier. How many of you have heard of Pester before? Yeah, one person. Pester is a PowerShell testing framework. So the downside of Pester is it's only Windows, unless the upside of Pester is it's only Windows. Like that's up to you. The third one there, anyone recognize that logo? Anyone know what that is? One that's above InSpec? That's the BATS logo. Have you heard of BATS as a testing framework? BATS is the Bash automation testing system. So you write your assertions, like that InSpec code, you write it in Bash, which is awesome or terrible. I don't know. You decide. And then there's InSpec. Now, I don't really care which provisioner you use. You could use Chef, you could use Puppet, you could use Ansible. I do care a lot about which verifier you use. You should use InSpec, because InSpec doesn't care which verifier you use. And I'll show you, if we get to it, some other things that are really cool about InSpec that will make you want that more. So we're at a point in the talk where my time is almost up. I have about, according to my watch, about 8 minutes left, which means I can cover probably 2 of the 4 topics here. So this is a time check. There, I've just checked the time, and then a CYOA. Do you all know what that stands for? Choose your own adventure. So here are 4 things that I could do. I could just stop talking. I could wrap it up. I could do questions and answers. I could show you some Terraform stuff, or I could show you some compliance testing. And the rule is the first thing I hear when you shout it out is the one that I'm going to do. Compliance testing was the first thing I heard. All right, so here we go. We are going to go, let's see, where'd that mouse go? We are going to click on compliance testing and go to that part. Come on, there we go. Also, it's a good moment for me to reflect on the summer is almost over. They're going to go back to school soon. It's cool. And to just take a breath, because I've been talking a lot. Okay, thanks. So some compliance testing. Let's talk about compliance testing. How many of you can tell me what this document is? Anyone? Anyone know what this is? Come on, the dude from MITRE, you got to know what this is. Yeah. What's that? It's kind of like this 171. Yeah. This is a CIS document, a Center for Internet Security. Have you ever heard of this? All right, so here's one thing that's super true about my journey as a sysadmin also. I'm working at this place. I've got everything automated with Chef. Everything's going gangbusters. We're moving all the time. My boss comes to me and says, hey, Nathan, next week the auditors are coming in. And I said, the who? And he said, the auditors. They're going to come in and they're going to give you these documents and they're going to have a bunch of rules in them. And you have to tell them that the rules are being followed by your infrastructure. I'm like, well, that sounds ridiculous. But I learned that next Monday, the #1 rule of the audit. You know what that rule is? get the auditor out of the building as fast as possible. Get the auditor out of the building as fast as possible. That's the rule. And the reason like it sucked is the auditor came in with a document that looked like this. And he said, Nathan, does your infrastructure follow these rules? And like, I'm used to automating. I'm used to handing my servers code and then it doing what I told it to do. I handed my server the PDF and it was like, okay, you want to just rest that here or what's the deal? What's going on? It didn't help me. It was terrible. So InSpec, not only is it a language that we can use to assert our automation did what we wanted and use that sort of rich descriptive language that we looked at there. We can actually extend that a little bit further to take all of these compliance and security controls that our auditors and our security department are asking us to follow, and we can turn that into code. Code that lives in a version control system so that we can track how it's changed over time. We can understand who gave us the reason why we can skip this control here, who made that change to the code, and so forth. InSpec is super powerful like that. So let's just take an example. Let's look at that. So here's a particular rule. Communication between network devices and central authentication systems must be encrypted at all times. Okay, so how do I take that and turn it into an automated test? Just like I did previously, I have this described. Here I'm describing an INI file. Its key should not be nil. So it should have some secure key that's in this INI file. That's the code. But with InSpec, I can take that test and I can provide a lot more context around that. So look at what I can do here. I can give it a control. I can give it a name. I can give it a title and a description. The description can match right from the PDF. But in addition to having it match right from the PDF, I can actually provide some additional context that's important to us. And so now we've essentially taken that PDF document that the auditors came in with, and we've turned that into code. Code that, again, lives in a version control system. When the auditor comes back next time, we can just execute this code and hand them the results. When the auditor says, hey, we said this one has to be enforced, but you're not enforcing this one, why not? We can go to the version control system and see, here's the special dispensation that we got to not have to follow that one, or here's why we were allowed to lower the priority of this one, or what have you. Now, as cool as this is, there is an amazing website that you absolutely have to check out. It's called dev-sec.io. What you will find at dev-sec.io is this: compliance profiles that follow many of the standards. So it will follow, as an example, the NIST standard and the CIS standard, except it doesn't say NIST or CIS on them because we kind of look at them. Here's the thing about standards bodies. Man, they are great at coming up with standards and writing down rules. And like NIST says your passwords have to be at least 24 characters long. And then the CIS says your passwords have to be at least 16 characters long. And so we say, well, let's just write one rule that says they have to be 24 characters long. It's the more restrictive of the two. So if you're passing that one, you're passing both of them. So some of the compliance profiles that you'll find here on DevSec.io are kind of a blend of those two. We want them to be the more restrictive of the standards bodies that are out there. So not only will you find those profiles that are free, they're open source, you can contribute to them. But in addition to those profiles, you will find chef cookbooks, you'll find Puppet manifests, and you'll find Ansible playbooks that do the remediation, that take all of those rules and enforce them. InSpec is just your checker. Your tools like Chef and Ansible and Puppet, those are your enforcers. So I test, and then I enforce. That's the difference between the two. So I'm going to take that Ansible playbook. I can add these tests right into my kitchen YAML very easily, so I can actually start testing these security things as part of my development process. No longer do I have to wait till I get into production and run a security scan to see what is my situation. I can test it before that code ever touches production. And I can integrate it right into Test Kitchen. So my verifier is InSpec. I have a set of InSpec tests. Some are local, test integration default, and some go out to GitHub. Go to the DevSec organization on GitHub and grab the Linux baseline. Grab that entire profile and let's execute it. So I'm going to kitchen verify. Let's see, I have that over here somewhere. Give me 1 second. So, whoop, you're not supposed to see that. All right, so here I have a system that was provisioned by Ansible already. I'm going to run kitchen verify. And this is using that Linux baseline. So it's just running against one machine in this case. I think it's in Ubuntu. And look at this. I have 57 tests that were successful. Profile summary, 26 controls were successful, 2 controls were skipped. So I have all of these controls that have already been executed against this. And in fact, yeah, that's that. So I'm going to skip past this part, but I'm going to publish all of these slides, so you'll get to see it all. This was us just using that playbook, executing it to do some hardening, blah, blah, blah. I have 12 seconds left, which is why I'm skipping through all of this. But it's cool. Like I said, I'm going to give you all the slides. One thing I want to leave you with, though, is a screenshot of Chef Automate. Chef Automate is our commercial product. So this is a screenshot of a customer. Of course, all of the data has been changed, but they're running InSpec in their production environment, and it gets reported up into our commercial product called Chef Automate, and they can come in every morning and they can see that they're executing 3.3 million controls across their infrastructure. They can see how many are failing, how many are passing. They can sort those by priority level and figure out which things should I go fix today. It's super powerful. InSpec is awesome. All right, since I have 30 seconds left, I'm going to wrap it up, and then if you really want to see some Terraform stuff, we can talk about that as well. So let me wrap it up. I work for Chef. Chef is awesome. If you haven't played with Chef, I definitely recommend that you play with Chef. If you have a tool that is automating your infrastructure today, and you did not build that tool, and it is successful, keep using that tool. So if you're using Ansible today and you're happy with it, keep using that. If you're using Terraform today and you're happy with it, keep using that. Also, Chef probably has a role along with that Terraform. If you're using Puppet, keep using that. The thing that you should take away from this talk tonight, if I'm successful, you'll say InSpec is a thing that I want to look into more because it doesn't care how you provision your environments. And hopefully you've started to get a glimpse, at least, that testing infrastructure automation is a thing that you can do. You can start doing that tomorrow with Test Kitchen. I'm going to be at DevOps Days Raleigh. So if you're looking for something to do in September, come on down. We'll get some good East Carolina barbecue. I mean, we'll have a good DevOps conversation in Raleigh, because that'll be fun. The thing that I love about this meetup, not dissimilar to a bunch of you, is it's local. I live in Annapolis. I spend way too much time on airplanes. So when there's an opportunity for me to come and speak at a meetup and meet a bunch of people that are local to where I live, I love that. One of the things that I used to do was run the DevOps DC meetup group. I've since passed that off to other people. It still meets every month. So there will be a meeting in September. I won't be at that meeting because I'll be on a plane down to Raleigh. But in October, the DevOps DC meetup group is getting together with a brand new meetup group called the Chaos Engineering Meetup Group. And they're having this inaugural joint meetup. And it's all about chaos engineering. Now, how many of you like smooth jazz? Because Nora Jones is going to be presenting at this.
Oh, really? Nice.
Not that Nora Jones. Sorry, it's Nora Jones from Netflix who does chaos engineering. Like maybe the soundtrack will be Nora Jones, but I tell you what, that oldest kid that you saw in the picture earlier, like that was his sleepy time music. So when Nora Jones comes on, everyone in our house gets a little sleepy.
She loves that.
I'm sure she does. Yeah. Yeah, I better not go. At least this isn't live streaming to the internet or anything. It's cool.
Where's that going to be? I know it's in DC.
Yeah, it's going to be at Rally Health in DC. I'm not sure. You go to the website and they'll tell you. If you're looking for other fun things to do, you could join us at the Chef Community Summit, either in Seattle or in London. Basically, the flights are about the same from here. So I'd say London. It's going to be, I mean, they're both going to be great. If you've never been to Seattle, come to Seattle. Otherwise, come to London. Or just do both. That's
Coffee versus
what's that? Yeah, they're both gray and rainy. In October, I can virtually guarantee that. But I should be at both of them, so that'll be fun. Or now you know, definitely don't go. I don't know. So you should get started with Test Kitchen. The best way, easiest way to get started with it is to install the Chef development kit. The reason that we say that, you're like, oh, I thought you said it worked with Puppet. Why are you telling me to install the Chef development kit? Look, here's the thing. Test Kitchen and InSpec, these are Ruby gems. If you've never managed a Ruby project before, you're welcome. If you have managed a Ruby project before, you know that keeping your gems, all of the gems that come together, like managing all of those dependencies and keeping a good set can be really, really a horrible, horrible job. So the Chef Development Kit just brings all of those gems together. They all work together in one install. You get everything that you need. You don't even need Ruby installed on your system. The Chef Development Kit has an embedded Ruby right within that. So you can get started with these things right away. You don't even have to do Chef with it, but use the Chef DK. Sorry, I call it the Chef Development Kit because a lot, like all the hipsters call it the Chef DK, but sometimes when you say Chef DK, people hear Chef Decay. And I don't like talking about the decay of Chef, right? So it's the Chef Development Kit. That's my preference. Anyhow, get that installed. And then your driver, you have to install whatever driver requirements you want. So if you want to run local VMs, probably VirtualBox and Vagrant you need to have installed. Of course, if you want to just run Docker containers locally, you can do that. GCE, EC2, whatever. Just make sure you have accounts there. I invite you to use, share, and contribute. Test Kitchen is open source. InSpec is open source. You can find all of the code from this presentation, including the code that I didn't show you, on these links. And these slides with all of the demos will be published to SlideShare probably tomorrow, including all of the demos that you saw. I don't know if you noticed or not, but they're all videos. So I'll embed those into the slide deck as well, so you can just watch them. And then finally, I'd love to have you join us in Slack. So actually, I should have put in another slide for the Baltimore Tech Slack. So if you're not in the Baltimore Tech Slack, you should totally get into that Slack group, because then it's a great way for all of us to continue this conversation after tonight. And I would tell you where to go to sign up for that, but I'm not sure what the URL is. So I'll post it. Do you know what the URL is for that, Kevin, off the top of your head? Yeah, we'll post it in the Meetup comments. So if you just look at the comments tomorrow or Friday, you'll see it there. But the Chef community has a Slack. We welcome everyone into the Chef community Slack, even if you're not using Chef. The good thing about, or one of the nice things about that Slack is there's a channel for Test Kitchen and there's one for InSpec. So if you're using either of those tools and you have new questions, come in and ask those questions. It's super good. All right, with that, I want to say thank you so much for coming out and listening tonight. I hope that you learned something. I hope that this looks intriguing to you. I will stick around for any questions that you have, and for the small set of you that want to do some Terraform, like I can show you, I can whip through those slides really quickly, show you some cool stuff. And I just ask that before you leave, if you could do two things, maybe three. The first is make sure that if you have cups or plates or napkins, make sure they make it into a trash can, please, because Under Armour is awesome to host us, and if we leave the place a mess, they won't do that again, so that would suck. The second thing I ask you to do is make sure that when you leave here tonight, you met at least one new person between the time you walked in the door and the time you walk out the door. So maybe you've already done that, but if you haven't, and I don't count, because you can't say, well, I know that guy, I listened to him for an hour. That doesn't count. You have to meet someone else before you leave. The third thing, if you want stickers, there's some cool stickers over there by Brian. And I don't know, there might be other folks with stickers that you have to share. The way that you can tell if someone is good at DevOps or not, the true measure of a DevOps engineer is the number of stickers on their laptop. Also, for every asset tag you have on your laptop, you lose 2 DevOps points, just saying. So that's like all of that is a lie, for sure. With that, I'm gonna say thank you again. And if you're watching the live stream,